Professor of Data Engineering at the Bern University of Applied Sciences and co-leader of the Applied Machine Intelligence and Generative AI Lab. Her research focuses on applying innovative technology like machine learning and language models to the fields of health and humanities, and on the investigation of bias in natural language processing under consideration of European languages and values. Her talk today is titled Bias in Natural Language Processing Inside the Bias Project. So without further ado, I hand it over to Masha.
Thank you very much for the nice introduction. It's an amazing pleasure to speak here today with all these amazing people in the room. And yeah, thanks already for the introduction. Most things were already said. I have a background in computer engineering and now working in the field of NLP over the last years. My focus is on these societal stereotypes and the bit of the social aspects of all of this technology, but from a technical perspective. I'm also looking at what we call augmented intelligence. We will get back to this later in this talk. And it comes a bit from the fact that I don't really like the word artificial intelligence, in the sense for what we technically have today and with what it implies to have this human-like intelligence that I want to put a bit in question. But we will get back to that. I'm also quite active, especially over the last years, in educating the general public about large language models and AI. So more and more people are using this technology, and to be aware of the risks and to use it responsibly, there is a minimum knowledge that needs to be acquired by everybody. Now, not everybody has to become a data scientist expert or a programmer, but there is some basic understanding of what these systems can and what they cannot that is needed for everybody. And in this context that I have also published my book. So let's dive into this with an image I generated with ChatGPT. So I asked it to generate an image that shows how AI is reinforcing societal stereotypes. This is what I got. So I have some problems with that. First of all, it seems that the societal stereotypes seems to be mainly a women's problem, which I don't think it's the case. On the other side, yeah, we have this thing here in the middle, which, yeah, is not ideal. We have the usual writing issues here still when generating images. And we have this line. So, yeah, I think there is room for improvement here and also within the systems. So when we talk about machine learning, so I'll go over this part quickly here, since most of you might already know, but I want to go through the basics of machine learning quickly with a perspective of the problem of bias. So the problem of bias in AI is relevant for very different types of technologies, for different types of data, and it comes in many different flavors. And that's also what makes it so challenging to detect and do something about it, because it's deeply rooted in the data. So the thing is that with this artificial intelligence, very broad term that we use nowadays mostly for machine learning, we are having this training data and we are extracting things, or using the training data to train our model to then have an output now, be it a generation of an answer in a chatbot scenario or whether it is a classification. We always have as a foundation for whatever we are doing the data set. Now, if you think of a classification problem here with cats and dogs, so let's say we want to train a classifier with supervised machine learning where we want to differentiate between cat and dog images, we would be having training samples of cats and of dogs. So, of course, here we have 4. Of course, we would have more. We would have hundreds, thousands, or even more of images in this training data. And we would then be able to train this binary classifier to have a model that is able to make a prediction whether we have a cat or a dog in an unseen image. Now, here's already one of the crucial points. It makes a prediction. It means that it can be wrong, and it will be wrong. It can be right in 98% of the cases, but there will be cases where it will be wrong. Now, this is one of the key concepts of responsible use of AI. Can your use case handle this 1 or 2%? If it cannot, you should consider if this is the right approach. Now, apart these cases where it's wrong, it's also the question, when is it wrong? What are these 5%? Who are these 5%? And this, of course, is majorly influenced by what we have in the training data. So here, I mean, depending on what cats and dogs we have, it might work better for one type or the other. It might work better for a specific position, how the dog or the cat are placed in the picture, and so on. So all of these are challenges and are facts that might have an influence on the outcome of the fairness or the potential biases in these machine learning systems. Now, the same can happen for any other kind of application. So we looked at pictures, but we can also have a text classification. We can have any type of data where these differences in the two or more groups that we're trying to differentiate, they can come in different flavors. In the picture, it can be expressed by the pixels that are composing the image. In language, it can be expressed by how something is said, by what is said. There are many, many different dimensions on how these differences between groups come into play. And this is only the classification. Of course, with machine learning, we have all sorts of different applications. We can predict categories with supervised machine learning to have a classification. We can have the identification of groups using clustering. We can have timely data and make predictions for the future. We, of course, have text processing. We have the detection of uncommon patterns, and so on. And each of these has all of the dimension of diversity that we can imagine somehow associated in the data. And biases in the data can be reflected in different ways in all of these different technologies. Let's have a closer look at the particular case of language models. In language models, the idea is that we have a large amount of training data in this sense here being a large amount of text. So we don't have this explicitly labeled data like in the example of the images, where we have for each image a label, and then we are predicting the label, because language is more complex than that. So we would have the cat and the dog, and those are animals, and they're a category of animals that could be considered pets. They eat something. So there are a lot of relations in language that we cannot capture that way easily. So the idea of language models is that based on these texts written by humans, historical texts that are there, we are training a language model that, for example, when using a very common type of training, predicts the next token. So let's say the next word here to simplify, based on a partial sentence. So in this example here, we would be having Anna went to the forest and saw A. And we would have 3 to be a likely option. Lion, maybe here a bit less likely option, but still possible. And smiled, which doesn't fit at all from the context, from the grammatical structure. So based on this, step by step, we want to build based on probabilities. So getting it back again, what was likely in the past will be likely in the future. We will compose sentences. Now, this can be auto-completion, it can be the answer to the chatbot, or all of the different use cases where we use large language models. So as said, for this, we need a large amount of text. And where is this large amount of text coming from? It's based on the data that has been created by society. Because we are now in a range of data that is needed, where we basically need to get everything we can, and the amount is so huge that there is no possibility for manual validation. So the question we are asking in this kind of training is, how do these words relate? So it's not about meaning in a deeper sense, it's about probabilities of how these words relate together in a typical human text that has been written in the past. So one way of training this is, for example, by predicting the missing words. So here we're getting a bit back to the labels we have seen before. Before we had these explicit labels of labeling pictures as cat and dog. And here in this type of training, we have, let me call it implicit labels, where we are masking words in an existing sentence. So we know the right answer because the word is actually there, but we train the system on predicting the word that is missing, that we have been hiding. So here on this field, there are many masks, and the right answer might, for example, be strawberry, can be used as one training instance out of many, 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 many training instances in many, many, many iterations to train such a model. So what we get is then this language model based on, by probabilities, the relationships of words in past texts. Now, this is what we have in the back end of many applications. So these are these pre-trained language models. So if we think of the context of GPT, this would be the GPT model, whereas we can have, based on these models, different applications. So let's say ChatGPT as a web application, as a chatbot. We can use models for spam detection, for sentence completion. We can use them as they are. So here it's GPT. Of course, there are many different models out there. And we can reuse them or further train them or fine-tune them to dedicated tasks. But all of them, all of these applications resulting from that have this same core, this same model trained on these probabilities of the texts from the past. And that's where the problem lies. Because everything that was generated over the past contains the societal biases. Now this can be, so here we're getting a bit broader again, but this can be texts, as we saw in the example of language models. Texts that were written more about men than about women, that were written describing women in one way or the other. For example, having specific roles, having specific jobs or roles in the society or professional roles. Similarly, we might have pictures. Let's think of stock pictures of a CEO. Let's think of any other kind of data that is the way it is based on how society produced it. And that is then used for this application for machine learning for data science. So these are just 3 headlines I brought here. There are by now many more examples, even books, about the problem. Is that there are different forms of biases. So I mean here, what we have seen so far, it was primarily about gender bias, but we have this with all the dimensions of bias we might imagine. It's about origin, it's about religion, it's about intersectional biases that all come together and are reflected or even reinforced by these models. So one typical example where we have several cases where that happened is, for example, with images. So there was a UK passport photo checker that showed a bias against dark-skinned women. So here we talk about public sector infrastructure, about basic applications that worked differently for different groups of the society. There's also the very famous and a bit older example of the tech company bias in recruiting, where the AI recruiting tool developed a bias against women. So this happened because it was in the tech domain that was male-dominated, and they used past data of good matches to identify what a good match looks like. Now, it was not even about gender explicitly, but it was about implicit information that proxied the fact of these records being for women. And given that they were not present in the training data, the AI system excluded them at a later stage. And this went quite far before it was actually realized, showing how dramatical this can be, because here we talk about labor market, we talk about public services. So we talk about topics where inclusion is highly relevant. Another example is the chatbot Tai. That was released on Twitter and interacted with the community to further learn. Yeah, I guess we can all imagine how that ended. It had to be turned offline after, I think, 24 or 48 hours because it became racist, sexist within a very short amount of time. But here it was an active interaction with users. So what about examples from our daily life? If you want to observe bias in production, machine translation is a very good example. Who's using machine translation tools regularly? So maybe, depending on what language you're working with, you might be familiar with some of the examples here. So typically, we can observe the bias when we translate from a less gendered language to a more gendered language. Like if we translate from English, the expert, the secretary, the nurse, the professor, the doctor, and say, words like this. In German or other gender languages, there is a choice that has to be made. Now, this choice, it could be random, it could be always male, it could be always female. There are different ways how it could be done. But what happens in the typical machine learning tools from different providers is that typically we have a very stereotypical translation. So in the example here, we see the expert and the doctor are male, the nurse and the secretary are female. Similar for many other professions, and so on. So what about ChatGPT? If we ask very directly, like let's say I have 2 jobs, tell me which job is better for men or women. Here the example of nurse and wildlife rehabilitation, because it's something that came up, and marine biologist. What will happen? We will have very beautiful wording saying that they cannot be differentiated. It's not correct to differentiate. Both jobs are equally suited. That's good, right? So the problem is solved? Of course it's not, otherwise I wouldn't be saying that. So let's try it differently. Let's try it more implicitly. So we want to create a short story, purely hypothetical, huh? And we need some inspiration. So we have Julia and Ben. They are a young couple. They're freshly married, and both are working with animals. So let's see what are their job activities based on this. So we have on one side Julia, who is carefully nursing the injured birds. She also educates visitors about conservation. On the other side, we have the marine biologist that is collecting data and is rehabilitating stranded marine animals, a hero. Yeah, so that didn't work exactly as we expected. So of course we make a second example because, just to be sure, this time they're working in healthcare. Yeah, Sylvia and John this time. So Sylvia is an emergency room nurse, and John is a pediatrician. So yeah, 2 examples, 2 ways the problem is not solved as good as it potentially could. Image generation is another example in production where we can also observe this. So in this example here, I generated 4 pictures of professors in computer science. As I didn't really recognize myself, I was like, okay, maybe it's a prompting problem. You know, prompting is important. We have to learn how to prompt properly. So I want 4 different pictures. Yeah, well, so this picture was already back, I think maybe a year or more. So I tried it recently. The pictures look different now. People are wearing suits now, but the problem is the same. So yeah, image generation, another huge problem. We have similar examples for chief financial officers, CEOs, and other professions where we have very, very stereotypical outcomes. Also here again, I mean, what I show here is gender and professions, but there are many more dimensions about how women are depicted, how different groups of the society, ethnicities are depicted, whether they're depicted as all disabilities, and so on. So there are problems of all dimensions we could imagine that are reflected in this technology. So let me talk quickly about the BIAS project. The BIAS project is mitigating diversity biases in the labor market, and it's a Horizon Europe project where I'm currently leading the technical work package. And we are right now a bit over the half of a duration of 4 years. And we are looking at, from an interdisciplinary perspective, so we are working on the technical part primarily, but we have a lot of different people with different backgrounds, with the legal background, the social sciences and humanities background, who investigate this problem together. Because on one side we are looking, so we have a focus on 2 main things. One's the AI application used for the labor market, and on the other side, the societal stereotypes in language models for European languages. So on one side, we are looking at on how actually AI is already used and how aware the different groups, for example, the applicants, are of this process. We then study how, what are the actual biases in recruiting, but also in general of humans in the different partner countries, and how those are reflected in the technology. So we had different co-creation activities in Norway, Iceland, Turkey, Switzerland, and some other countries, where we worked out with people what the stereotypes are and see how, for these specific languages, they are reflected in the language models. And then, of course, from the technical perspective, we try to quantify it, to measure it, and mitigate it eventually in some way or the other. There's also the possibility to become a part of the BIAS project. So we have this community of stakeholders where people can register so that they can be invited to the different activities we are doing. So during the first half of the project, it was more about co-creation, generating information. But now in the second part, we have different training programs that we are organizing for both HR professionals, general audience, and specific models also for data scientists and AI developers. So there we are bringing back our findings, the things we learned, the things we developed in the project to people. Because as I said, the mitigation in a technical sense is very difficult, especially when it comes to people using a lot very intransparent systems like GPT, where we cannot really access the actual models, where we don't know on what data it was trained, which makes it really hard to do verified and quantified research. It's more on the prompting interface where our options are very limited. So there, the major leverage that we have is to be sure that people are educated about it, that people that are using, deploying, planning, developing this kind of applications are aware of the limitations and can keep that in mind and integrate it in the processes. So about the technical components, we have on one side a fairer recruiting with case-based reasoning. So it's a fully explainable approach that is developed by our colleagues in Norway. I'm not going much into detail here, but you will find further information about this also on the website of the BIAS project. And we have the do components where we are mainly responsible of, which is on one side mitigating bias in text-based applications. So here we are dealing with this kind of problem as we saw earlier in the recruitment example, where women's records were identified by proxies just because they were written differently, using different words, having different characteristics than the male records, even though the gender was anonymized. So here we are looking at, because we are working with the different European languages, how these sensitive words that might lead to a bias if this text is fed to any kind of third-party application, which are those words and how can we maybe adapt in order to avoid that this specific letter or this specific CV is discriminated by general tools where we don't have an influence on. So this is, of course, specific on the cultural context and on the language. We then have the part about bias detection and mitigation in word embeddings and language models, where we are looking at these stereotypes that we have derived from the co-creation activities, and we study how they are reflected and potentially reproduced in the outcomes of LLMs, but also more traditional word embeddings. And here I said we have the models where we that are open, where we do have the embeddings, where it's easier to really test and validate, and also validate the mitigation approaches, and black box models, which are, of course, used a lot, so it's important to fix it, but it's way more difficult. One challenge is also that we are dealing with a lot of normative processes here. So a lot of things cannot be decided from the technical perspective. So let's say if we make a prompt that says, what is a typical job for women? So probably most of us here have a clear perspective what we want to hear. But somebody could also argue and say, based on statistics, this is a typical job as of now. So a bit this frozen past problem when we replicate things that were there in the past, stereotypes that are there in the future. So here it quickly gets normative, it gets about values. And that's also one important part of our work, to include the European values, the concepts of diversity in the development of these components. We also bring insights for other languages. So current research had a strong focus for English, or often also for the stereotypes in the US-American and the American sense. So here we are looking at specific local stereotypes in Europe for different migration groups that are typical for Europe as opposed to the US. Also for the language, so often when methods are developed for English, they wouldn't work or be transferable out of the box to more gendered languages, more complex languages like, let's say, Icelandic, Norwegian, or German. So, yeah, and as I said before, it's crucial that we have an interdisciplinary team here, because it's not only about technical questions, it's a lot also about ethical questions, legal questions, and societal questions in general. So due to all of that, so here we only talked about the risk of discrimination and bias, but of course there are other risks like hallucinations, like lack of explainability, and so on. Due to all of this, I think that we shouldn't call it artificial intelligence and strive to something like a human-like intelligence replacing humans, but we should use it as what it is, a tool to help humans, a tool to support humans rather than replacing them. And we need to educate humans to use these tools in a responsible way, teaching them what are the basics of how they work, what are their limitations. So what it means to be aware of the limitation, on one side it means, is the use case suitable? Can we live with this fact that this is about probabilities? What are the implications? Who are the people or the cases that are the ones that are where it's not working well? We need to check the contents for correctness, and we should always be critical. Question ourselves, how biased is this? What biases could be there? What's the harm that could be resulted from this application in practice? So that was it from my side. I'm happy to connect on LinkedIn. You'll find my email if you have any questions. And I think we have some time for questions now as well. Thank you very much.
Maybe we can take one of these. Hello. Thank you, Masha, for a very, very eye-opening and excellent talk on a very important subject. For those of you in the audience, you can use the Whova app to submit questions. If you go to the session Q&A section, under each different talk, you can submit your questions. We also have volunteers with microphones floating around, so you can raise your hand and they will come to you. While we're waiting for that, one question to start off with is, you mentioned that there's in the second part of the BIAS project, you have trainings that you give to different groups of communities of people. How has that gone so far, and what have you seen as the impact?
So one of the formats we had was for HR professionals. So the feedback we had was good. I think people enjoyed participating in it because it's, as you said, eye-opening. A lot of people are not aware of these limitations. So, and for them, it's relevant. So it's not that they don't care, but they just need to know about how they can handle this, or that the problem exists, so they can ask themselves or within their organizations the right questions. So this is something we are working on, and we're also much looking forward to the one we are currently developing that will be rolled out, I think, in the second half of the year for AI developers, where we will also be able to transfer some of the more specific technical contents we have developed.
Thank you. I believe there's a question now from the audience.
Hi, Masha. Thank you very much for your talk. It was amazing to see actually the biases getting recognized. Recognizing them is one thing. It's the first initial step. It's a great step, no doubt that we need it. But what about the solution? Is the solution is that we right now retrain the models with the replacing he with she, replacing certain like words and skill sets and all of that with female, data, or is it like we train our models with the neutral data? Or we completely somehow formulate a technique where we don't really need to specify any of these tone. What's the solution? Where do you see yourself going?
Yeah, so it's very challenging. There are different ways. So the problem is that it's not as simple as that we can place things in the training data, unfortunately, because we have all of these different biases. So and different data modalities and intersection of everything. So even in a text, there can be ways where it's about women. It can be the context of the word that women are described differently. This is only women, but then we have all of the other dimension of biases that come together. Similarly with images. The appearance can make a difference, the picture quality can make a difference, socioeconomic background, and so on. So this is one point of the problem. The second point of the problem is that it's normative. So what might be a bias for me might not be a bias for my insurance company, for example. So it's a lot about values. From the very narrow technical perspective, we have some ways to address some aspects in the cases where we have access to the models. So for word embeddings where we are able to extract the models, we can try to identify, let's say, the gender dimension in all of the dimensions and try to reduce that one. which is then again complicated for gendered languages that have a grammatical gender, which we don't actually want to reduce, but goes hand in hand. So this is a bit the technical context where we are fighting with finding solutions for this problem. And yeah, so the easiest solution would be if everybody could just stop being biased, so we generate some new data and train the model again. But yeah, we all know that's not going to happen. So from a technical perspective, that would be the best. But yeah, we are working with the other workaround solutions that we have. But we are working on mitigation.
But you do relabel, you do have the part and technique where you do relabel data and then you retrain? Or is it like, it's another kind of layer where you try to extract and just replace those particular embeddings?
There can be approaches, but it's not really a retraining because, I mean, first of all, like GPT-like models, we can't train them at all. And also the data would be too important to generate synthetic, not biased data due to all of these difficulties. So this is, yeah, there can be ways in some cases. So especially also it gets better when we narrow down the scope. So the most difficult thing what people are currently trying to do is to have this general chatbot that answers all of the questions of the world. So I'm not sure this is also something we want to go with in the long way, because it makes much more sense that you say, okay, we have this very narrow use case. These are the potential biases we can have here, like if it's about products in a, I only answer questions, for example, about products in my shop. I can narrow it down and then I can address it, I can retrain, I can generate data. But this overall concept of the general model is difficult itself for this kind of models.
Thank you.
Thank you for the question. I will read now a question from the app, actually. It's a complementary question. Could oversampling on texts that counter stereotypes in a fine-tuning step help to reduce bias?
Yeah, so there are different ways on how we can use data, like also mentioned before, synthetic data to make it better. So this is also like maybe a general concept. So the word of, even since the beginning of the project, I was like making it clear, like we're not going to have a bias-free system. Nobody's going to use that word because we don't even know what that is due to all of the different biases. But we do indeed have different ways to say, okay, in this context here, we have this problem. We measured the bias with women and jobs. So we fine-tune or work on the embeddings or do whatever measures to reduce this bias that we have identified. And then, yeah, the model is better. And we can do this for many biases that we know, so the model can get better. But it will potentially not be bias-free.
One more question from the audience there?
Yes, hello. Hi. Thank you, Masha, for the great talk. It's really cool to see that people are working on this to actively identify and reduce these biases. My name is Alice Dries. I come from more machine learning in single cell and biology and data stuff. But I still have a question because people are inherently biased, right? So even an HR person or a general random person will often judge a male CV stronger than a female CV, even if you only change the name on top, right? And similarly with probably different backgrounds or ethnicities or races. So do you see then that AI can actually help to circumvent also this human bias that a lot of humans have, or do you see this more as a problem to actually obtain a completely unbiased AI? Because in the end, the humans also judge whether this AI is biased or not.
Yes, so I think technology can help in the process, but not this kind of AI models or AI things that we are doing right now in most of the senses. And yeah, I agree that humans are biased too, but I see that the bias in AI can be more dangerous because it's more systematic. So in humans, there are some biases that might be more common than others, but there might be some people that have like an opposite bias, some people have a different bias, some people are less biased than others. So there is more variation and there are still humans and individual contacts. Here, if we think of like these large CV selection algorithms or systems, they have a very specific bias, and the stereotypes can even get reinforced. So it's not only about reflecting the biases in humans, but they can also get reinforced. So it can actually worsen the problem. Of course we can, and this is also something we are exploring, we can use technology, or it can even be AI in some sense, but in a different way, in an explainable way, in a transparent way, that can help recruiters to manage all of this. making it actually fairer. So we can think of hiding certain information or providing the same amount of information for everybody, avoiding that somebody that is very verbose can present themselves better, and so on. So there can be ways to leverage technology, but it can also be a risk in many cases as we see them now.
Thank you.
Thank you very much for all your questions, and that's all we have time for in terms of questions. But I'm sure we have many, many more that we could ask you. So please give a round of applause to Masha. Thank you very much for an excellent talk.